Hello students, in this video we find out how to compute the second derivative of a parametric curve with respect to x. So if we're given a parametric curve, given that f is x of t and y is g of t, then if we can write y equals f of x, then we can say, if I can do the t derivative of both sides of the equation, this would say that dy dt is equal to df dx by the chain rule times dx dt. That's just the chain rule, which allows me to conclude that dy dx, which is the same as df dx, so dy dx is dy dt over dx dt. Now, what this tells me is this says in order to do a what? In order to do an x derivative of something, so I'm going to write this symbolically now to help us figure out why this next result is true. So this tells me that in order to do an x derivative is equivalent to doing what? Is equivalent to taking a t derivative of whatever you input, and then dividing that result by dx dt. Okay? So what that tells me now is that tells me that d squared y dx squared is really the x derivative of the y derivative, which is the x derivative of what? Which is the x derivative of this ratio over here, dy dt, dy dx, dy dt, sorry. So let's do that. Okay, so dy dx. Now what is dy dx? dy dx is going to be dy dt. So let's write dy dx. And now let's do this again, so just be redundant over there. And so now this is the same thing as doing what? This is the same thing as doing a t derivative of what? A t derivative of dy dx, which is a function of t, and dividing that by dx dt. So there's our result. Our result is that the second x derivative is equal to this expression over here, d squared y dx squared. So there's our result. All right, so let's see an example of how we would compute this. So for example, let's look at this curve over here. Our curve is x of t is going to be cosine of t plus t sine t. And our y of t is going to be sine of t minus t cosine t. What is this curve over here? Of course, this curve is just the involution of the unit circle, right? So this is just the involution. Okay, so let's do the first derivative. What's dy dx? dy dx is going to be what? Is going to be dy dt, which is going to be cosine of t minus what? Minus cosine of t. And then the derivative of cosine over here is going to be negative sine, so I'm going to have a minus t sine t, all divided by what? The t derivative of x, which is negative sine t, then plus sine t, and then plus t cosine t. So it looks like the dy dx is going to be what? Is going to be the t sine t over t cosine t, so that's just going to be tangent of t. Great. Now let's do the second x derivative. So what's the second derivative? So d squared y dx squared, by our rule, is going to be the t derivative of the y derivative divided by what? Divided by the x derivative. Of course, the x derivative is down the bottom. What is the dx dt? dx dt is exactly what's right over here, which is t cosine t. So it's going to be a t cosine t, and that exactly is the what? This thing over here is really just dx dt. So I've done the t derivative of the y derivative and divided by dx dt. Great. Now, of course, the top is just tangent, so this is going to be d by dt of the tangent of t over what? T cosine t. Now, derivative of tangent is secant squared. So this would be what? So it looks like I'll have a 1 over t. That's going to turn into a secant squared over here, secant squared of t. Of course, 1 over cosine is also secant, so it's going to be 1 over t secant cubed of t. So that is the second derivative of y with respect to x for the involution of a circle. Thank you very much.